But by designing a structure to withstand quakes, Wang creates a new challenge. Tall buildings sway in high winds and even risk collapse in extreme storms.
And Taipei 101 is no exception. In fact, it's not just windy, it's smack bang in the middle of a typhoon hotspot.
Typhoons, Asian hurricanes, can batter Taiwan 3 or 4 times a year. In 2007, 160-kilometer winds kill 9 and cause $100 million of destruction. To keep Taipei 101 standing in a superstorm, CP Wang turns to an engineering solution developed 3,500 years ago. To discover this ancient engineering secret, I'm meeting Ken Maschke from the company that helped design Taipei 101. Ken wants me to try sailing, but not in an ordinary sailboat.
Ken?
Hey, Richard.
Hi, how you
Come
doing?
on board.
It's narrow, light, and has no keel sticking down into the water for stability. So how can it stay upright against the wind? This extra hull, one of 2, is the engineering connection this craft shares with Taipei 101. And why Ken's got me on a sailboat.
Now it's got me working.
These clever devices are called outriggers.
There it goes.
They keep a sailboat stable in high winds.
Look at that.
Before we hoist sail, Ken explains the basic principle of the outriggers.
If you stand with your feet together and I shove on you, you're likely to fall over. If you spread your legs, it's going to be a lot tougher. Now, the same thing, in essence, is what we've done here. We spread out the distance between which the force acts.
The idea of outriggers goes back 3,500 years to the Polynesians. Using them meant the early mariners could paddle or sail fast and stay stable.
I just hope these outriggers work as well for me today. Looks a bit cold in there.
With sails up and stabilizers out, it's time to see if we can push Ken's theory to the limit.
I can't believe the speed of this thing.
Today, using outriggers like these, yachts can sail across the Atlantic in just 4 days.
Can this go over?
Yeah.
Would you mind awfully if it didn't? When it works, it really works. I can see how these outriggers work on a boat, but the same theory on a building. How?
The outriggers are part of the wind-resisting system, which includes a central core that's very stiff, but not stiff enough by itself. So we add these outrigger trusses to transfer force out to the exterior columns, like the pontoon that you're standing on right now. We can take the outrigger idea and apply it all the way up the building. So actually in Taipei 101, we have outriggers every 8 floors.
On every 8th floor, the outrigger columns connect to the horizontal trusses, the ones inspired by bamboo. So, when typhoons strike, Taipei 101 is braced to withstand the tipping force of the hurricane winds, thanks to an idea developed by the ancient mariners.
And here is an outrigger doing its job up here on the 86th floor of Taipei 101. It's helping the building resist the forces of the wind whilst freeing up plenty of rentable floor space around the central core. So you're looking at money in the bank.
And that's the point of tall buildings: maximum floor space for minimum footprint.